Okay, so welcome to the third video for Unit 4 over ionic bonds. The number one thing that you need to take away from this video, if you don't even watch the rest of it, is one thing. An ionic bond is between a metal and a nonmetal. This is something that will carry on to the next unit. You need to get this in your head. Ionic is a metal and a nonmetal. So what is an ionic bond? Basically, an ionic bond is a transfer of electrons between a metal and a nonmetal. And what happens is it creates two ions, and those ions are going to be attracted to one another, and that creates a very strong bond. So for example, we have sodium and chlorine, and this is a compound that you know of as salt. And how this bond actually forms between sodium and chlorine is sodium is in group 1, so he's got one valence electron. Chlorine is in group 17, and it has 7. So what happens is because chlorine is extremely electronegative, it's actually going to take this electron away from sodium, and it's going to fill its outermost shell, and sodium is going to be left with no more valence electrons. Now, when this happens, if sodium lost an electron, it's going to become a positive 1. If chlorine gained an electron, it's going to become a negative 1. So there is a strong attraction between these two atoms, and it creates a very strong ionic bond. So when you have an ionic bond, there's two things that are created. First thing you need to know is any ionic compound is called a salt. So you guys know salt as sodium chloride, which is table salt. But if I say the word salt, I could be referring to any ionic compound that we discussed for the rest of the year. Next thing you need to know is there is a repetitive crystal lattice structure. The ions will arrange themselves in this alternating pattern. And this is why ionic compounds tend to be very strong and very stable. And it's very hard to break it apart. Okay, so there are some properties that you do need to know about ionic compounds. The very first one is that ionic compounds are solid at room temperature, and this is due to their strong bonds. It's actually very hard to melt a ionic compound. They have very, very high melting points, and this is again due to their very, very strong bonds. They do not conduct electricity when they are solids. The electrons in these bonds do not move. And so when they're solid, they don't conduct electricity. But if you dissolve them, the ions will actually break apart. And the ions freely moving around will cause a good conductor, a good solution. And we'll talk about that second semester. And the very last thing, they're brittle and hard, and again, this is due to those very strong bonds created between those two positive and negatively charged ions. Okay, so something that we're going to be drawing for the remainder of this unit is called a Lewis structure. You guys have drawn these before in 8th grade. Lewis structures are where you draw how many valence electrons an atom has. And so let's do the ionic compound of calcium chloride. That is calcium, which is the metal, and chlorine, which is the nonmetal. Now there is two notes that you need to make real quick off to the side. You need to make a note that metals give away their valence electrons. Remember, they become positively charged cations. Nonmetals will take those valence electrons away and become negatively charged, and that's all due to electronegativity. The electronegativity of nonmetals is very high compared to the metals, and this is why nonmetals are able to take valence electrons. So we have calcium and 2 chlorines. So we're going to draw a calcium and 2 chlorine atoms here. Now if you look at the periodic table, calcium is in group number 2, so that means it has 2 valence electrons, so we'll draw 2 dots around it. Chlorine is in group 17, and so it has 7. And so you have to draw 7 dots around each of these chlorines. Now, this chlorine, remember everybody wants 8. So each chlorine only needs 1 to be happy. So what's going to happen is it's going to take one away from here, from that calcium, and the other one is going to take the remaining valence electron. And so what you will create is a positively charged calcium, and it lost 2, so that means it has a positive 2. And over here, you've got 2 chlorines that now have all 8 valence electrons. So you draw 8 dots all around them, but don't forget they added 1, so it's going to have a -1 charge on both of them. Now if you notice, overall we have a -2 charge here, and then we've got a +2 from the metal, and that actually balances it out. That's very important. Ionic compounds are actually neutral, but there are positively and negatively charged ions within the compound. So this creates a very strong bond between the calciums and the calcium and the chlorines, and that's how you draw a Lewis structure of an ionic compound. Okay, so you need to write your summary for this video. First thing you need to answer is, what is an ionic compound? You need to make sure that you include that it has a positive and a negatively charged ion in the bond that causes it to have that strong bond and attraction to another. Next thing you need to know is what is created by an ionic compound, and then what are the properties of those ionic bonds. And then definitely take note, how are those Lewis structures drawn? Remember, metals give and nonmetals take those valence electrons. Very important concept that you need to include in your summary.